All right. Hello, everyone out there in audio land. Welcome to the first episode in what we plan to be an ongoing series about two very important topics, hi-fi and beer. I'm Brent Heffley. I'm the Sales and Marketing Director for Ayre Acoustics. To my, this way, there we go, flip camera, is Ariel Brown, our designer and chief engineer. And right there below is Ryan Berry, our CEO and expert technician. So if you came here expecting a polished, well-scripted video about how great Ayre is with dramatic background music, you are in the wrong place. This is a casual conversation about hi-fi, about beer and fun, and we hope we can provide something interesting. So first topic of the today, what are we drinking?
So we're probably nearly the most local brewery to Ayre. This is Ayre Brewing. It's a pretty large brewery at this point. It's still considered, a microbrewery, but they're pretty big.
Yeah, I remember they moved to that new building, which was super cool.
Yeah. They incidentally, when at our old location before we moved almost 3 years ago now, and before Ayre moved, they used to be almost as the crow flew, just a few hundred yards away.
Dangerously close, as we used to say.
Yes, we had some former employees who liked to lunch there frequently.
Yep. I don't know who that would have been.
And they're certainly not a kin of mine. So
No.
So they moved and we moved, so now we're close again. And it was completely coincidental, I promise.
Well, what was interesting, I looked on their website earlier today, and they started the exact same year that Ayre did. They
really?
In 1993. I was like, wow.
I had no idea.
Some good cosmic energy.
I wish they got into the beer industry then.
Right?
Yeah.
Excellent. So yeah, I couldn't find any out here, amazingly enough. I'm guessing it's something with the distributor and the shortage, and I went to 4 or 5 different places, called some, and there's none available. So I'm having a little Cascadia Kolsch this afternoon. So that's my substitute beer. I'll try to get on the same page with you guys next time. So
nice. Yeah, we have opted for their one of the really light-ish, easy drinking White Rascal Belgian white style. I enjoy a lot of their beers. A lot of them are much stronger, which I'm going to try and refrain from because I don't need to spill too many company secrets in these discussions. So I don't need to get that lubricated.
Excellent. Yeah, I think this Kolsch is only 4.8%, so that's a nice before 5 o'clock somewhere beer.
That's right.
Cool. All right. Well, I picked today's inaugural topic because it kind of covers one of our basic tenets of design, and it's about balanced. There's a lot of stuff out there about balanced connectors, balanced cables, balanced circuitry, balanced in the analog realm, balanced in the digital realm, differentially balanced. So I know that I've had a lot of questions over the years, and I think a lot of people go, "Oh, good, it's balanced," but I don't know that they really know what all that can mean, or what doing it right or doing differentially balanced versus a basic balance means exactly. So let's dive in and talk about that. All of our products are balanced, and
sure. Yeah, and so I think the first distinction to make is that in general, balanced usually refers to cabling and connections, and when, as it applies to circuitry, you really want to call it differential. So when you're talking about any kind of active circuitry or any kind of like amplifier circuit, that's probably more correctly called a differential amplifier or differential circuit.
Uh-huh.
Now, and so we kind of combine the two because we, all of our connections, all of our signal routing, and all of the circuitry is done in as balanced as we can physically make it. And we use differential circuitry to take advantage of what the balanced signaling allows you to do.
And I think that's a real important distinction because balanced is a loosely used term at times, and
Right.
not all balance is created equally. So, there's a big difference between having a fully globally balanced or differential amplifier where you have a dedicated circuit path for each of your phases versus having XLR connectors on an amplifier and doing things with op amps and then having a single-ended signal path throughout the amplifier itself.
Yeah. So all of our analog products we've ever made have been fully balanced inputs, fully balanced outputs, and fully balanced differential signal path all the way through. Which and because we do complementary circuitry as well, which is kind of where we have bipolar power supplies plus and minus, and we have basically push-pull, almost differential circuitry in that direction as well. So we have, on average, 4 times as much circuitry as a typical single-ended amplifier.
Right, which sounds just crazy, to somebody coming and going, wow, does that mean that Ayre products are 4 times more expensive than they could be? So we obviously know that that's not the whole case because the chassis
Right.
parts cost a lot,
Sure.
basic circuit boards, a lot of those things do, but we
Yeah,
are adding
a
lot more parts. So what's really the end benefit of that? Like, I think the prevailing belief is, balance prevents external noise. Like, it prevents external noise from coming in, but it really does more than just that.
Yeah, well, the balance and differential, and so balance signaling ensures that any noise that is picked up by the cabling or the signaling is picked up equally in both phases. And then when you use a differential circuit to receive that, it can then, anything that was picked up equally can then be canceled out. So that's and that's very, very well known, and it's commonly used, especially for microphones where you have a very low level signal, very high impedances, without balanced signaling, without differential amplifier, you would never be able to get a very usable or high, microphone signal.
Right.
So there is that. There's definitely the benefit of basically rejecting any noise that can be picked up along the way in the cabling or even circuit board traces anywhere. We keep all signal balance, balanced signaling. Then we can cancel out any of that picked up noise. In our case, another big benefit of the balanced and differential circuit is, and it's hard to talk about this without talking about one of our other tenets, which is feedback. And so in our case, we'll probably have to talk about this separately in a different discussion, even though it's somewhat integral to this, but suffice to say that our differential balanced circuits allow us to get respectable distortion without using any feedback.
Right, right, because feedback's used in a lot of cases just to reduce the distortion numbers without taking into account the other effects that it has on the audio signal, which,
right, and that's,
as you mentioned, we'll talk about in another video at length, I'm sure.
And that all kind of goes to, what Ayre's always stood for, where it's not about trying to filter out things that get into the signal path. It's about not letting it get in there in the first place. And that's where balance really becomes a key factor for us. And that's why, while it is expensive, there's no getting around that. It does take twice as many components to make a balanced signal for each channel as it does to take a single-ended. Not doing that means we would have to resort to things that would be correcting a bad signal down the line, and that's not something we would want to do as a company.
Yep. Yep, for sure. Now, can I get my office balance so when my kids are arguing and making a lot of noise, I can just flip a switch and cancel them out? Or is that a different technology, more like the noise canceling headphone?
I think if anybody invents that technology, they'll be the richest people in the world.
Right.
Awesome. Let's put that on our to-do list.
Yep.
We will do.
Absolutely.
Yeah.
Maybe.
So I should point out one of the other benefits of our, the way that our differential input stage is configured is that it accepts a single-ended connection very elegantly and naturally converts it to a balanced signal from then on out. And also without any loss of amplitude, because actually, if you had a 2-volt single-ended signal and versus a 4-volt, as is described, balanced signal, those would come out the other end of our circuit at the same level.
Right.
Because the differential input circuit basically induces equal and opposite signal through our differential input stage.
However, from a purist standpoint, it's still more beneficial to have balance from the beginning to the end of your design.
Absolutely.
So, the more components you can have that are balanced and the interconnects being balanced, that all adds up. And, having single-ended anywhere in the circuit does possess a negative to the overall sound quality.
So let's touch on that for a minute, because in most of our audio world today, it's digital music. With cartridges, right? They are inherently balanced.
They are inherently balanced, yes.
Right. So with analog, you're good to go unless you decide to go single-ended somewhere in the path. Like you can start from the cartridge itself. But with digital, how does it work in the digital realm, getting to a balanced signal?
Well, so I mean, the digital realm, there's differential signaling, which is pretty extremely rare, I would say, as on the digital side of things. And in the digital realm, we're still just talking about just a represented binary number, and so it doesn't. You don't need to cancel any noise yet. Now, there are benefits to differential signaling as far as radiation and as far as other noise created. But in general, it's not necessary in the same way it is now. So where you get back to a differential or balanced circuit is at the DAC chip. So the DAC chip is where digital converted back to analog, and so any high fidelity DAC chip will have a differential output.
Okay.
So, and what that does is basically, at any value, it is going to create equal and opposite amplitude values on the plus polarity and the minus polarity. They're not created, there's not separate paths before that point. It is generating that equal and opposite signal right at that output stage of the DAC chip.
Right. Okay.
And then it can be treated exactly as we do any of our analog circuits, where all the signal routing is all match length, matched impedance routing throughout the circuit board. I try really, really hard to keep my routing equal length and spaced.
That's actually a really good point. Actually, Ariel's design acumen, I should say, is phenomenal in the sense of how the boards are designed. They're a piece of art because, as he said, the signal paths have the same length. Having everything exactly mirrored is not a small task for anybody. And to be able to do that where your traces are the same length going from each portion of the circuit to the next portion of the circuit so that, everything is treated exactly equally is a monumental task in a circuit board design. And it does take a considerable amount of time to do correctly.
That's huge. Do you think we'd still get the same result if we let him out of his office at night to go home?
No, definitely not.
Yeah, I didn't think so. That's cool. One of the things that we've talked about the noise and stuff and rejecting the noise, but I think that's also important to look at where the noise can come from, right? Because it can come from a few different places. It can come from external noise in terms of Wi-Fi and radiation, different signals, but it can also be generated internally by power supplies.
I'm actually really glad you brought that up because, there is one thing that we do that's probably a little different than a lot of the audio companies out there, particularly in our use of transformers. We use an EI core transformer, and they're known to radiate more than a toroidal transformer in the same rating. The EIs are a little more directional, so you can play with that, but they do nonetheless have more of a noise that they radiate off of them. So balance becomes really huge in being able to reject that. Now, the reason we've used EI is because there's several benefits from a sound quality standpoint that makes them the choice in our book. We've used toroidals in the past in some of our early designs, and eventually moved on to the EI cores and had much better results with them. But that balance becomes key. Without the balance circuitry, we wouldn't be able to do that.
Right. Yeah.
Yeah, and because of the use of our our differential circuitry as well as what is termed complementary circuitry. Any both picked up any picked up radiated power supply noise as well as any power supply ripple left over is then also rejected and canceled by the active circuitry. Now that doesn't mean that just because our differential circuitry rejects most of the power supply noise, that doesn't mean that we slack off on our power supply design. Sure. It's we still go to great depths to make sure that our power supply design is as noise free as possible, because it's not a infinite rejection. There's you can get 60, 80, 100 dB of rejection depending on how well the various transistors in the circuit match each other. Will kind of affect just how much of that noise is actually rejected. So,
right. So the matching of those parts, those components, can play a big role in that piece.
Absolutely.
Yeah, something we do very painstakingly around here. We spend quite a bit of time matching every component that we put into the boards to ensure that both sides are treated equally, and then of course we test to follow up on that to ensure that they do work as we expect to once they're in the circuit.
Nice. Yeah, that's a lot of.
And that's that's really just the internal side. I mean, you have things like power supplies. Nowadays with digital, with Ethernet and USB and everything makes some noise in a circuit. And so we do things, as Ariel said, to minimize things as much as possible, such as switching off sections of the circuitry that aren't being used at the time and so forth. But at the end of the day, you need to have a pretty robust design to be able to reject that. And then externally as well, you have long runs of cable. Some people will run 15, 25, 35 foot runs of cable, and they're big antennas at that point in time. And a lot of money and a lot of effort is put into trying to isolate cables as much as possible.
Yep.
Many of the companies that do this, and they specialize in cables, are experts in their field. But, physics are physics. They're long runs of wire, and they can pick up noise. So having a balanced run in that case definitely minimizes the amount of what they will pick up for you, and, gives you a lot of benefit in the long run.
Right. Now, in the balanced signal, it's easy for me to imagine that or picture that in my head in terms of going through the C player, the preamp. But when you get to the amplifier and you've gone through the main amplifier stages and you're ready to go to the output, what happens there? Like, how does that balanced signal translate out to the speaker and that whole connection?
Yeah, so I mean, it's not really that much difference, except that that at that final stage, the speaker itself actually becomes essentially part of the output stage. It is just a load across the output buffer, the output amplifier, and so we essentially have there's basically an output buffer, which is the positive phase, and an output buffer, which is the negative phase, and they basically alternate pushing and pulling depending if the signal is positive or negative at that point. And so then the impedance of the speaker, often on average 8 ohms, but it varies across frequency. Then it's basically push-pull output stage. And so it's just equal and opposite. And so, a lot of, there are many power amplifiers have a single-ended output. And so the negative or the black output will be connected to ground. And so and the biggest difference there is then that has its termination will have a different impedance, as opposed to the output impedance of the buffer itself.
Okay.
And so you can try to match that with a resistor, except that an active output will have a dynamic output impedance depending on frequency.
Sure.
And so again, having that balanced output stage, then have matched impedance on both lines, push pull equally, and in our experience, it's the ultimate way to do it. And
right.
There is a small cost in as far as parts in doing it, but it's well worth it.
Right. Very cool. So I think we've covered a lot of it. What do you guys think? Would we ever make a single-ended product? Something that wasn't fully balanced?
It's expensive to make very high-end products, and the balanced is obviously the true way to do things in our minds. So it's hard to imagine doing a single-ended product, but there's definitely reasons to do them for companies, and I'd never put down anybody that does one, because you can hit price points to make your offerings more accessible for people, and there's a lot of draw to that. There would be significant development hurdles to overcome, particularly with having no feedback and having something a little more susceptible to being able to be affected by noise within and without the product. But Ayre's always been, if nothing, innovative and finding ways to do things that hasn't been done before. So it's not outside the realm of possibilities to me.
Yeah. I mean, with our circuit, there are again, we would have to maintain our differential input stage, but that can still be reused with single-ended inputs, and then circuitry after that could be reduced if we were talking about just a single-ended output. So there are some gains that could be made there to be able to hit a price point. It is possible.
Yeah.
But as far as if we were trying to make the best of something, there wouldn't be a draw to go single-ended over balance. There's really no benefit outside of that to the single-ended design. So we will obviously always aim to design balance first anytime we can.
Right. All right. Wonderful. Any other thoughts on balance? Any other things you guys want to throw out there before we wrap up this pint?
I think it pretty well covers it. I think that it's one of those things that as you learn about what balance can do in your system, it becomes something that you realize the benefits to, and until you've taken that time to actually start replacing those components, it's kind of difficult to understand the benefits and keyword, or it's really just use fancy words and high-end audio like balanced and zero feedback and differential and everything, and it's when you get to experience these things it really starts to make sense. So I'd highly encourage anybody that was thinking about it to do a test run, do a demo, and find out what listening to something balanced is versus listening to something with op amps that convert from single-ended to balanced and so forth.
Yeah, absolutely.
Yeah, and I think that there's plenty of systems where any kind of noise rejection would not really be an issue, and so I think there's plenty of systems where where single-ended connections would perform just fine, would not create excess noise and would sound just fine. I think where our balanced technology comes into play is that because we go to such great lengths in the circuit routing and the circuit design to allow for optimal balanced and differential circuitry, and we pay so much attention to detail in that gains less technical benefits, but it gains benefits just from that attention to detail in the circuit layout and design.
Right.
Even if it's not necessarily necessary for noise rejection in that person's scenario.
Mm-hmm.
I think the way that we do the balance benefits everybody, regardless if it's single-ended or balanced.
Right. Whether they're using a single-ended source or a balanced source, the other details really make a big difference. Yeah. One last quick question. This is a kind of a loaded question because I already know the answer, but a lot of balanced connections, when you go in, they have a clip that clips in and locks it into place, and
the clip.
And we don't do that.
Yeah, and it's one of the examples of where Ayre is obsessive about the best quality of everything. And the reason why that clip's removed is because it's made out of a magnetic material across the board. Every one of the manufacturers for those XLR inputs makes a magnetic, ferrous metal clip. And one of the things that we've learned is that magnetic material has a huge negative impact on the sound quality of our of the signal. So we go to the point of we make sure that the capacitors we use often don't have steel leads. They get replaced with specialized leads for us. The screws in the transformer terminals that we connect the wires to are non-magnetic. The screws that hold the entire unit are all stainless steel to have them as low magnetic or as little magnetic as possible. And the chassis, of course, are all aluminum for that same reason. This is no different. The clip is a magnetic source, and it's right next to the output or the input of the product. So, it's where you definitely do not want to have anything like that sitting right next to your signal path. And so they get
even though it's not even in the signal path, it is close enough that it's surprisingly enough.
Yeah, years ago, Charlie actually learned about this with Gary Mulder, and Gary and Charlie were listening to some music, and Gary said, "Watch this," and he took a steel pipe, and all he did was he laid it next to the XLRs, and going in from one product, or going from I think it was the V3, going into the preamp that was feeding it, and you could just immediately hear the sound change. And then you put it away,
Wow.
and it was better. And then you put it there again, and it was worse. And they've
we are totally doing that at the next audio show that we do at Demo Ad. If there are any of those again.
Yeah, if we ever have them again,
if we ever have one of those again, I'm bringing a steel pipe. And
similarly, the ferrites, we used to have ferrites in some of our products, and they sounded better. And we found that over time, they got worse and worse and worse sounding. And if you replaced the ferrite, it was good again.
Right.
But the ferrites just lose their effectiveness and actually become detrimental to the sound. Right. Over time. So, we had to pull all the ferrites from our products as well for that same reason. And it's just anything magnetic is a bad thing is what it comes down to. And so you need to get it out of the product as quick as possible. So it's really frustrating when I see, high-end products, and then we see stamped, steel back plates, which is the entire back plate of the unit. Mm-hmm. And, to save money and to, bring costs down, and knowing what it's doing to the sound. They had a great product, and then, to throw that chassis piece on there,
right,
took it down for them.
Yeah. All right. Well, I guess the takeaway here is balance good, magnetic bad.
Magnet's bad.
I think that's something we can all cheers to.
And balance is not all created equal.
Yep. All right. Well, thank you everyone for joining us today. We hope you enjoyed our hi-fi banter here. If you have questions you'd like to see us address in other episodes, email them to me at pints@ayre.com. I'll put that up on the screen. And then until next time, cheers and happy listening.
Cheers.